Yes, students, good morning and welcome to our journey for part 2. Part 1 we completed and very soon I am going to give some homework regarding part 1. Now students, today we are going to start chapter 4, limit of part 2. Very interesting chapter, very easy chapter. Theories are only some 6-7 definitions. So students, in part 2 we have less theories compared to part 1. Now students, if I start with some basics, real number line. Real number line. All of you have studied the number line. A number line or a real number line is such a line where, say, the points P, Q, R, S, A, B. Suppose this corresponds to minus 2.3, this corresponds to minus 1, 0, 1. 1.5, this corresponds to say 2. A number line is such a line where point on the line corresponds to real numbers. Once again, a number line or a real line is such a line where points corresponds to real number. There is one-one association between points on the line in set of real number and such a line is called real number line. So in short, I can write points associated to real numbers. Such a line, students, is called a real number line. Now students, in mathematics we have concept of intervals, which is very useful in statistics also. Basically, there are two types of interval. First is open interval and second is closed interval. So in general, in mathematics, students, we have two types of basic intervals. The first is open interval and the second is, students, closed interval. Using these two intervals, students, we can make two more intervals which I will explain. Now, first of all, define open interval. Students, define open interval. All of you pay attention. The first definition is, students, define open interval. Say suppose I write like this, open interval 2, 7. And suppose I write x belongs to this interval 2, 7. So students, x will be any real number between 2 and 7 excluding 2 and 7. X can be 2.1, x can be 3.18, x can be 6.99999, number of 9s you want to add, but x cannot be 2, x cannot be 7. So if I say, students, x belongs to open interval 2, 7, x can be any real number between 2 and 7, students, excluding 2 and 7. So the definition is, let A and B be real number such that A less than B. As per our example, you can understand A as 2 and B as 7. A and B are real numbers and definitely 2 is less than 7. So let A and B be real numbers, A less than B. Then set of real numbers lying between A and B, excluding A and B, is called, students, open interval A comma B. Set of all real numbers between A and B, excluding A and B, or not including A and B, is called, students, open interval AB. So here, if I write x belongs to open interval 2 comma 7, x can be any real number between 2 and 7, but not 2 and not 7. So once again, definition of an open interval: A and B be real numbers, A less than B. Set of all real numbers lying between A, excluding A and B, is called open interval AB, and open interval AB is written in this form, and the set notation is x such that A less than x less than B and x belongs to R. The set notation of open interval AB is x such that x is between A and B, and definitely I can say x belongs to R. So here I can write x such that 2 less than x less than 7, and definitely x belongs to R. So this is called, students, set notation of open interval AB. So in general, for any open interval, if I say x belongs to open interval 2 comma 7, x can be any real number between 2 and 7, excluding 2 and 7. The second is, students, closed interval. The next is, students, closed interval. Now suppose I say x belongs to closed interval 2 comma 7. Small bracket denotes open interval and square bracket denotes closed interval. Now what is the change? X can be any real number between 2 and 7, including 2 and 7. In closed interval, endpoints are included. So if I define, then I write AB belongs to R, A less than B. Then closed interval AB means, if I say x belongs to closed interval AB, means x can be any real number between A and B, including A and B. So what is the set notation? X such that A less than or equal to x less than or equal to B, x belongs to R. Here only less than is written, here less than and equal to, because in a closed interval, endpoints are included. In a closed interval, endpoints are included. So what is the definition of closed interval? Once again, all of you pay attention. A and B are any real numbers, A less than B. Set of all real numbers between A and B, including A and B, is called, students, closed interval AB. So what is the basic distinction between closed interval and open interval? In open interval, endpoints are not included. In closed interval, endpoints are included. So this can be written as x such that 2 less than or equal to x less than or equal to 7. And definitely, students, x belongs to R. So once again, students, pay attention. We are revising all three definitions. What is a number line or real number line? On a real number line, there is 1 correspondence between points on the line and real numbers. Every point is associated to a unique real number, or every number is associated to a unique point. In mathematics, students, we have basically 2 types of interval. First is open interval and second is closed interval. What is open interval? Suppose A and B are any real numbers and A less than B. Set of real numbers lying between A and B, excluding A and B, is called open interval AB. Open interval AB is denoted by small bracket. Set notation is X such that A less than X less than B, X belongs to R. Then closed interval. Let A and B be any real numbers, A less than B. The set of real numbers lying between A and B, including A and B, is called closed interval AB. Set notation is X such that A less than or equal to X less than or equal to B, where X belongs to R. Here only less than, here equal to. Now using this, I can make another 2 intervals. First is open closed and second is closed open. Say suppose I write open A, closed B. In open A, closed B, what we have to write as definition, students, pay attention. Let A and B be any 2 real numbers, definitely A less than B. Set of all real numbers lying between A and B, including B, but not A, because at A we have open. Let A and B be any 2 real numbers, A less than B. Set of all real numbers lying between A and B, including B, but excluding A, is called open closed interval. And the set notation is X such that A less than X less than or equal to B, and X belongs to R. Then closed A, open B is X such that A less than or equal to X less than B, X belongs to R. Here A included, B excluded. So definition, the first 2 lines remain same. Let A and B be any real numbers, A less than B. The set of all real numbers lying between A and B, including A but not B, is called closed open interval AB. And the set notation we have already written. So in mathematics, students, the concept of interval is very, very important. Broadly speaking, we have 2 types of interval, open interval and closed interval. After open and closed, using the open interval and closed interval, we can formulate another 2 intervals, of which the first is open closed and the second is closed open. Students, do write these set notations 5 times and definitions 3 times. Okay students, now we are going to define modulus. Now your basics are clear or not. This concept which I am going to teach will make your all basics clear. And students, you have to be very attentive in part 2, because part 2 is carried forward in all your graduation courses like BCom, BBA and BCA or CA or CS or MBA. So limit is such a topic where its application is unlimited, and students, you have to be very, very careful in the definition. Now students, modulus. What is modulus? Now the word you are familiar with. That answer of a modulus is always positive. Now see students, the definition is like this. Mod x is x when x is greater than or equal to 0, and mod x is minus x when x is less than 0. %99% of you are misguided. How modulus can be minus? But students, if x is less than 0, minus x will be positive. To Why modulus of a negative number becomes positive? Because one more minus sign is multiplied. Say modulus of 2.3 is definitely 2.3 because x is equal to 2.3 is greater than 0. Now modulus of minus 3.8 is written as like this, minus of minus 3.8, x and a negative sign, so it becomes positive, and x is equal to minus 3.8 is less than 0. Why modulus of a negative number changes to positive? The answer is one more negative sign is multiplied, which makes negative into negative positive, and that is why modulus answer is always positive. So we are writing mod x is equal to minus of x when x is negative. This x is negative, one more negative sign is multiplied. That negative sign into negative sign makes the value positive. So why modulus of a negative number changes to positive? The answer is one more negative sign is multiplied outside. So this is the generalized definition of modulus, which students you have to remember till you study. So somebody tells you that mod x is minus x when x is less than 0. Is this value negative? No. If x is negative, minus x will be positive. Why modulus of a negative number changes to positive? Because students, one more negative sign is multiplied. One more negative sign, students, is multiplied. Clear? All of you understood? So this is how, students, we have to remember modulus. Now students, our first definition is the definition of neighborhood. This word is very interesting. In the test, students, you use the concept of neighborhood, isn't it, students? In test, you basically, students, use the concept of neighborhood, copying from the neighbors I need to say. Now students, all of you pay attention. Just now we have studied the concepts of interval. How many types of interval, students? We have two. One is open interval, other is closed interval. In short form, we remember like this. In open interval, endpoints excluded. In closed interval, endpoints included. Now let me explain with an example. Say 3.7 is a real number and 3.7 belongs to open interval 2, 8. Yes or no? 3.7 is a real number and 3.7 belongs to open interval 2, 8. As this open interval 2, 8 includes 3.7, 2, 8 open interval is called neighborhood 3.7. Sorry students. 3.7 is included in the open interval 2, 8. So, open interval 2, 8 is called neighborhood of real number 3.7. I can even write like this, 3.7 belongs to minus 2, 7. Yes, I can even write 3.7 belongs to 0, 4. Yes. So, any open interval containing the real number A is called neighborhood of A. All of you understood? So, let A be any real number. Any open interval containing A is called neighborhood of A. So, what is the definition? Let A belongs to R an open interval, mind you, it is definition, an open interval containing A is called neighborhood of A. Is called neighborhood of A. So, in general, any open interval containing a real number A, mind you, according to definition, which interval? Open interval containing A, students, is called a neighborhood of A. So, as per our example, A is equal to 3.7, which is a real number, and this all open intervals are including 3.7. So, these open intervals are neighborhood of A. The most important MCQ from this definition is true or false, a real number A has infinite neighborhoods. Correct? I can write infinite open intervals which includes 3.7. So, one real number A can have, students, infinite number of neighborhoods, and according to definition, neighborhood is always an open interval. According to definition, neighborhood is always which type of interval? Open interval. Once again, what is neighborhood? Let A be any real number. Any open interval containing A, students, is called neighborhood of A. Theoretically, one real number A has infinite number of neighborhoods. True or false? True. I can write infinite number of open intervals containing real number 3.7 as per our example. Clear, students? So one has to be very careful, students, in defining neighborhood. Now the second definition is delta neighborhood of A. Second definition is delta. This is read as delta neighborhood of A. This is our second definition. Having defined neighborhood, now students, I am defining delta neighborhood of A. Let A be a real number and delta be non-negative real number. Non-negative means either 0 or positive. Students, what do you mean by the word non-negative? Either 0 or positive. So what I am trying to define this, let A be a real number and delta be non-negative. Non-negative means greater than or equal to 0. Then open interval A minus delta to A plus delta is called delta neighborhood of A. Try to understand, students. Let us take an example. Suppose A is equal to 5 and delta is equal to 0.2, which is greater than 0. Then open interval 5 minus 0.2 and 5 plus 0.2, which is nothing but 4.8 to 5.2, is called 0.2 neighborhood of 5. Delta neighborhood of A, delta is 0.2 and A is what? 5. So pay attention. A belongs to R as a real number. A is equal to 5 is a real number. And delta is a non-negative real number. Delta is distance, students. Distance can never be negative, which is 0.2 greater than 0. Then open interval A minus delta means 5 minus 0.2, which is 4.8, and 5 plus 0.2, which is 5.2. This open interval definitely includes 5, and this is called 0.2 neighborhood of 5. Delta neighborhood of A. So delta will speak first. A comes at the end. So in general, how to define delta neighborhood of A. All of you pay attention. Let A belongs to R and delta be non-negative real number. Non-negative real number means, students, greater than or equal to 0. Then open interval A minus delta to A plus delta is called delta neighborhood of A. I have given the example. As per our example, A is equal to 5 belongs to R. Delta is pointing to, of course, positive. Open interval A minus delta means 5 minus 0.2, 4.8. A plus delta means 5.2. This open interval is called 0.2 neighborhood of 5. So this is nothing but delta neighborhood of A. Delta neighborhood of A is denoted by N A delta. How to read this? Delta neighborhood of A. How to read N into bracket A comma delta? This is read as delta neighborhood of A. The notation form of delta neighborhood of A is N A delta, and that is nothing but open interval A minus delta to A plus delta. Of course, A is a real number and delta, students, is a non-negative real number. Delta is always in terms of distance. If I draw number line, students, then you can understand more better. Still, this is a number line. So this point is A. So this is open point. This is open point. Because in open interval, endpoints are not included. This much distance is delta, and this much distance is also delta. This point will be A minus delta, and this point will be A plus delta. All these points are included, but A minus delta not included, A plus delta not included. So, students, let us revise the two definitions of neighborhood. First is only neighborhood. Let A be any real number. Then any open interval containing A or including A is called neighborhood of A. According to definition, neighborhood is always an open interval. Second, define delta neighborhood of A. Let A be any real number, delta be a non-negative real number. Open interval A minus delta to A plus delta is called delta neighborhood of A, denoted by N A delta. This symbol, this box is read as delta neighborhood of A. So today's concepts very important, students. Once again, I am not going into other conceptual details. Let us revise all the definitions and conclude the lecture. What is a real number line? A real number line is such a line where points on the line corresponds to real numbers. There is one-one association between points of the line and real numbers. Basically, students, we have two types of interval. First is open and second is closed. Now, for open interval, remember, endpoints are not included. For closed interval, endpoints are included. Then, using these two intervals, we can make open closed and closed open intervals also. Then, students, I have defined modulus. Mod x is f(x) if x is greater than or equal to 0. Mod x is minus x when x less than 0. Students, when x is negative, minus x will be always positive. Why modulus of a negative number changes to positive? One more negative sign is multiplied. Then, let A be any real number. Any open interval containing A is called neighborhood of A. Practically, one real number can have infinite number of neighborhoods. The second definition was delta neighborhood of A. Let A be a real number and delta be a non-negative real number. Then open interval A minus delta to A plus delta is defined as delta neighborhood of A. Symbolically, delta neighborhood of A is written as NA delta and its interval form is A minus delta to A plus delta. I have shown this number line. So write today's concepts and definitions thrice. Next time we will do 2 more definitions and start exercise 4.1. Thank you, students.